Definition of the common log. Y equal to log base 10 of x. We can write log of x without the base, and we will understand that is the base 10. From the graph, you can see that they graph the log base 10 of x in the pink color, and in the blue color y equal to 10 to the x. They are symmetrical with respect to the y equal to x. In the example 7 below, I will show you how to graph the log base 10 of x, the common log. In example A, problem A, we want to find the domain. So we will set x minus 1 greater than 0. So the domain is x greater than 1. So 1, infinity. In part B, we want to graph the function f of x equal 3 log base 10 of x minus 1. We will begin from f of x equal log base 10 of x, and then we use the transformation. We can either use the calculator because we have the log base 10 in the calculator, or we can convert this into the exponential equation. This is a 10 that you do not see, and we will write 10 to the y equal to x. We will make the table, and it will be easier for us to make y first. So we make y negative 1, 0, and 1. And then we have negative 1, 10 to the negative 1, 10 to the 0, and 10 to the 1. And then we plug in the points. We got 1, 0, 10, 1, and 0.1, negative 1. So this is the graph of log base 10 of x. Now we go back to our function. We need to move this to the right one step and multiply the y part by 3. I will do the multiply first. So we keep the x part the same. So 0.1, 1, and 10. So we will have 3 of log base 10 of x. So that will give us negative 3, 0, and 3. So I multiply the y part by 3. So the y part by 3, the point 0, 1, 0, and then 10, 3, and 0.1, negative 3. And after that, we will move this graph over one step to the right. So I'm gonna wrap at the same time. So I will draw the asymptote first, and that will give us x equal to 1. And then every point we will move one step to the right. And the pink color is the function f of x equal 3 log base 10 of x minus 1. You can fill out the point 2, 0, 11, 3, and the point in the below is 1.1, negative 3. In part C, we want to look at the graph and determine the range and the vertical asymptote. So I want to copy part A again. So the next one, C, the domain we found from part A before is from 1 to infinity, and the range we got this one from the graph is from negative infinity to positive infinity. The vertical asymptote is x equal to 1. And in part D, we want to find the inverse function. First of all, we write the function in terms of y. And then we want to write in the exponential equation. We need to get rid of 3 first. So I will divide both sides by 3. So we got y divided by 3 equal log base 10 of x minus 1. And then this is base 10, so we draw the arrow. So we get 10 to the y over 3 equal log. We need to change to the x also, right? So we change to x over 3 equal log base 10 of y minus 1. And then we will convert this into the exponential. So 10x over 3 equal y minus 1. And then we solve for y. So 10 of x divided by 3 plus 1. We write in the function notation, so f inverse equal 10 x over 3 plus 1. In part E, we want to find the domain and the range of the f inverse, so I will go back to part C and then answer the domain and the range of the inverse. So the domain of the f inverse will be the range. So it's equal to the range of the range of the f inverse will be 1 infinity, and the domain of the f inverse will be negative infinity to positive infinity. In part F, they want us to graph the f inverse. So when we graph the f inverse, so we can verify part E, the domain and the range of the f inverse. We look at the f inverse, we can use the transformation for this. In the book, they already graph for us, and we can see that we just simply plug in the point for the f inverse, x equal 3 or 0 and negative 1, for example. Then you can see that they are symmetrical with respect to the line y equal to x. And we look at the pin graph, we can find that the domain is negative infinity to positive infinity. The range is from 1 to infinity.